So okay, so now what we are going to do is, uh, so in the earlier topic we saw, given an undirected graph, how to assign the directions to edges such that all the vertices are part of a directed acyclic graph. So now what we are going to do is, given again an undirected graph, how to assign the directions to edges such that all the vertices are in one single strongly connected component. Okay, so on this given graph, on that graph I'm going to assign the directions, and now after you assign the directions you have a directed graph. Now if you run the algorithm, the process that we just saw for finding strongly connected components, you'll be able to find that all these 7 vertices are in one strongly connected component. So that's what we want to achieve. Okay, so how to do that? Given the undirected graph, run depth first search on this undirected graph. So you all know how to do that. We have seen this particular graph itself several times. So I'm going to assume you know how to do that. So we have the edges classified as tree edges and back edges. So that's what we're interested at now. So you draw what is called this depth first search tree involving the tree edges and back edges. So 1 is the vertex from which we started depth first search. So 1 is the root of the depth first search tree, and from 1 you can go to 2, that's like a tree edge. From 2 you can go to 4 and 7, so those are the 2 tree edges, the child nodes. From 7 you have a back edge to 1, that's the back edge 7 to 1. And then from 4 you can go to 3, that's a tree edge, from 3 to 5, and then 5 to 6. And then the back edge is 3 to 1. Then 5, 4 and 6, 4. So I'm just redrawing this graph in a tree fashion, top to down, so that's easy to visualize. Okay. So once you have drawn the depth first search tree starting from the root, all you have to do is to assign the directions is this. So for every edge in this undirected graph, you want to assign a direction. So we are going to assign the direction following this rule. Now make sure before you assign the direction in this undirected version, okay, of this depth first search tree, make sure there are no bridge edges. Now we all know what a bridge edge means, right? So bridge edge means if I remove that edge, that undirected graph should get disconnected. Okay, so you can again cross check. So we went through the whole process in a earlier topic, how to determine whether an edge is bridge edge or not. So just do it, let us do it one example case here. So we're looking at this edge 1, 2. So we have the vertex 1 is closer to the root, in this case the root itself. So we have to look at now the subtree starting from 2. That means 2, 3, 4, 5, 6, 7 form a subtree. And now from this subtree, check if there's any back edge that either goes to 1 or something above, to a vertex above 1. In this case, there are 2 back edges, one back edge from 7 to 1 and then one back edge from 3, between 3 and 1. So if there's even one back edge that goes either to that vertex u or above u, then that edge uv is not a bridge edge. That's what the process we went through. So 1, 2 is not a bridge edge. Similarly, you could conclude every edge in this graph actually is not a bridge edge. You can check, say for 4, 3, 4 is now vertex u that is closer to the root. So look at the subtree starting from 3, which is just involving 5, 3, 5 and 6. So that means you are going to have, look at for back edges from this subtree. So you have one back edge that between 5 and 4, and then another back edge between 6 and 4, and then one back edge actually that goes from 3 to somewhere above 4. So because of all these things, we can say this edge 4, 3 is not a bridge edge. So no edge in this graph is a bridge edge. So once we have made sure that the undirected graph does not have a bridge edge, so this is like a prerequisite. So you cannot assign directions just arbitrarily and make all the vertices to be in one strongly connected component. In order to assign directions and make all the vertices to be in one strongly connected component, this is a prerequisite. There should not be any bridge edge in the given undirected graph. If there is even one bridge edge in the given undirected graph, then we cannot proceed. So in exam, I could give you an undirected graph that has one or more bridge edges. So if you find out that the given undirected graph, after you identify the tree edges and back edges like this, has one or more bridge edges, you can stop right there and say I cannot assign directions to the edges because this given undirected graph has one or more bridge edges. Now if there are no bridge edges, we can proceed and we can assign directions to edges and make all the 7 vertices to be in one strongly connected compound. So now how to assign the directions? The rule is this: for a tree edge, the direction should be from away from the root. So 1, 2 is a tree edge and 1 is the root. So you should assign the direction in such a way that the edge is pointing away from the root. So that means the direction should be from 1 to 2. Similarly 2, 4, 2 is the vertex that is closer to the root. So the direction should be from 2 to 4, away from the root. Okay. So similarly 2, 7, 2 is closer to the root, 7 is further away, so the direction should be away from the root, so from 2 to 7. So that's how we assign the directions for the tree edges. Now for back edge is the opposite way, so the direction should be towards the root. So 7, 1 is a back edge, so the direction should be towards the root. Similarly 3, 1 is a back edge, so the direction should be towards the root. 6, 4 is a back edge, so the direction should be again towards the root. That means you proceed closer to the root. So after you assign the directions to the edges, this is what you're going to end up with as a directed graph. Now we can cross check whether from any vertex you can reach any other vertex. You could, yes. So they form one strongly connected compound. You need not check. Just if you want to cross check whether you assign the directions in the right way, you can cross check. Automatically they'll form one strongly connected component. Okay, we're almost done. We have just one more example to go through. So let me stop with this. So what we'll do is, let me just save this video.